All right, here's your common assessment practice problem for this semester. So after you watch this video, you can go download your common assessment quiz, complete it, and then upload it to Canvas via the correct link. All right, so it says the bobcat population in the Everglades region of Florida has been declining over the last 20 years, largely due to the establishment of the Burmese python as a self-sustaining breeding population. Suppose the bobcat population in the Everglades region was 120 in 1985. In 2005, the bobcat population was 20. Let the variable t represent years since 1985. Identify the independent and dependent variables. So what we want to remember is which is x and which is y. So the independent is the one we are allowed to choose. So this is your x variable. The dependent is the one determined by the independent. So our dependent variable is going to be our y. That's terrible V. Variable. All right, so that's not enough. So when we are identifying, it needs to be in context of the problem. So our x variable, which we're calling the letter t because the years are determining the number of bobcats, which is our time, and it is in years since, I believe it's 1985. Okay, so once again, it said identify the independent and the dependent. So I'm going to come over here to the side. This is my independent, and I'm just going to abbreviate it. Now I need to identify my dependent. So it doesn't say which letter to call it. So right now I'm just going to put y equals because I don't know what variable we're going to use just yet. So I'm just going to put y equals the population of bobcats. Bobcats. And it is technically in the Everglades, so I'm just going to put Everglades. Everglades region, because this is not like nationwide or statewide or anything. All right, and that's it. All right, question 2, form a table to represent the population of bobcats in terms of years since 1985. Calculate the average rate of change, slope, of the bobcat population over time. Round to one decimal place if necessary. Include units on your answer. So we're asked to do quite a bit here. So one thing at a time, form a table. We're representing the bobcat population in terms of years since 1985. So if you want to call it x equals t, which is our years rather than equals, I'm just going to put years. And then my y equals the bobcat pop. So you can do your table horizontally, vertically. I like vertical tables. So I'm going to run it in two x and y columns. All right, so let's go back up and see what we were given. So it says in 1985. So we're determining our population in years since 1985. So our t value is not going to start at 1985. 1985 has been 0 years. So this is going to be the t value 0. It says the population was 120. Then in 2005, so you should be able to do that math there, but if you're questioning your subtraction, we're looking at how many years has 2005 been since 1985, so we're going to subtract the 2. So 2005 minus 1985 is 20. The population was, what did it say? The population was 20. So after 20 years, population has decreased down to 20. All right, so here's my table. Then it says calculate the average rate of change. Remember, average rate of change is that formal name for our slope of our population over time. So if we recall, slope formula, m, is our difference in our y's, y2 minus y1, over the difference in our x's, x2 minus x1. And remember, our x's are t's, so if you wanted to write it t2 minus t1, you could do that as well. All right, so our slope is going to be y2, 20 minus y1, 120, over x2, 20 minus x1, 0. So then again, depending on how comfortable you are doing your math, if you need to do your division, do your division. So we're going to take the difference in the numerator, difference in the denominator, and then divide the 2. And when we divide the 2, we're going to get -5. So there's our slope, but make sure you read very carefully. It says round to 1 decimal place if necessary. We got an integer, so it is not necessary, but then be careful. Include units on your answer. So if your answer does not have units here, it is going to be counted wrong. So I'm going to come back down here and I'm going to say, okay, my slope is m equals -5. And as far as the units are y per x. So if I go look at my units for y are bobcats. My units for x are years. So bobcats per, or you could use the division bar, year. So there's my table, there's my slope. All right, 3, in a complete sentence, describe the meaning of your answer average rate of change from what we just did above in context of the situation. So that means rather than just saying the slope is -5 bobcats per year, explain what this is meaning. All right, so because remember our time is slope, time is years since 1985, so I'm going to say since the year 1985, the bobcat population in the Everglades region, because that's the only place it's tied to, Everglades region, has been, and I'll zoom out where you can see it in whole in a minute, decreasing, key decreasing because it's negative, decreasing by 5 bobcats each or every year. Now be careful when you write that out. So when the word decreasing, that covers the negative. So if you say decreasing by -5, that's a contradiction. It's a double negative. So be very careful about that. Decreasing when it's negative, slope increases when it's positive. So since the year 1985, the bobcat population in the Everglades region has been decreasing by 5 bobcats each year. Done. All right, example 4, or question 4, using the table and your slope from 2. So we've got our table in question 2 and our slope in question 2. Write a linear function f of t. So this right here, remember f is the fancy label for y. So this right here identifies what we're going to be calling our y variable. That gives the bobcat population in terms t of years since 1985. And then a second part, use that function to estimate the bobcat population would be in the year 1990. And again, include units on your answer. So we're asked for a couple of things. So 1, equation. So our function, f of t, remember this is linear function, is going to be mt, because remember our x variable is t, plus b. M is our slope, b is our y-intercept. So if we go back up to question 2, our slope was -5. So I know from 2, so I'm just going to put this little note here. From 2, my slope is -5. And then if I look, I need my y-intercept. So remember, y-intercept is when your x or your t or your time is 0. We also have that in our table. It is 120. So we know m is -5 and b is 120. So there's my 2 variables. Then I can go plug them in. So my function f of t is -5t plus 120. So here's our function. So there's problem 1. All right, then there was a second part. Use said function to estimate what the bobcat population was in the year 1990. So again, be careful. We are not plugging in 1990. T is years since 1985. So if you need to do the math, do the math. So we take our stopping year minus the year we started at 0, and 90 minus 85 is going to be 5. So we are going to be plugging in 5 for our variable. So when t equals 5, that means we are calculating f of 5. So replacing t with the value 5. So -5 times 5 plus 120. And then we do our math. -5 times 5 is -25. We add 120 and we get 95. So there's the prediction. But again, it does say include units. So I'm going to come over here to the side and I'm going to write, it always looks better in a sentence, in the year 1990, the bobcat population, I'm going to abbreviate population, is estimated at, or estimated to be, what do we say, 95. And again, units on your answer, bobcats. Okay. All right, so here's your practice problem. Once you have watched this video and gone through it, then you can go work your common assessment and upload it to Canvas.